So it's time for the upper surface. But before we go ahead and do that, I think we should clean up a little bit the layers and so on and get rid of geometry and things that we don't need for the moment. It makes it easier to work in 3D. So let's put these curves into a layer. Go from a flat view. Let's try to trace the upper surface now. And as you know, the golden rule is to have as few CVs as possible. In this case, I use the default CV curve, which builds up a curve each time, or make a new CV and build up the curve along the way. Instead of the other one I used earlier, the edit point curve that goes from start point to end point. Here I try to add more CVs, and then you see it goes crazy, and maybe it would be easier just to go back and make a new curve with a higher degree instead. So in this case, I thought it was easier just to redo that. Remove the CVs and always think about the flow of CVs. So the flow of CVs is the straight line between the CV points should be as smooth as possible each time it turns. So think about that. So tweaking and moving CVs here, trying to establish a nice flow CV layout. And of course, tracing the silhouette. That's the goal. And we start to come a little bit closer here. And I think we have just enough CVs. Always use the curvature fence to check what it looks like. And now we realize when we zoom out that we have a crazy curvature there in the end. So just by moving that CV a little bit further away from the start CV, so the two CVs are not so close to each other, we calm down the change of the curve. The direction changes slower, and that is easily visible with the curvature fence or the curvature tool. Call it whatever you like. The curvature graph. Yeah, nice. I think we have a good start now for the upper curve. So let's get rid of the curvature fence. And if we look at this, we could be a little bit strategic about the lower boundary here. So maybe if we try to be in between the recess and the air intake, so we go right there in between, it will make it much easier in the next step. So we don't have the recess or the air intake split it up on two surfaces. Sometimes that is of course necessary, but now we have a possibility to make it a little bit easier for ourselves. So be strategic. So we copy one of the isoparms, the mathematics that already exists, and that gives us a very clean curve on surface with few edit points. And you do that with rebuild. You could get rid of that patch precision tool that is giving you a virtual grid. The good thing with patch precision, it doesn't burden, it doesn't make anything heavier. It's just a visual thing. Same procedure as before. I make a help surface. Again, you might not need it, because in bi-rail we could use something called implied tangent instead, just toward a curve when you have a symmetry plane. But I prefer help surfaces. So now we need a cross-section profile, and now I introduce blend curve here, which is a great tool when you make a transition because it blends. Listen to the name, blend curve. So just by clicking on the border there, you can see that we're almost all right. We add a point somewhere and click in the middle there, and the star gets white, and then we could move a little bit inwards there. So that looks good. You see the circle there? It means that we have G2 curvature continuity. 1, 2, 3 CVs are lining up. We don't need that. It just makes it flatter in the top or where we have the symmetry plane. So let's go down to tangent, and then it releases and the circle is gone. But if we click on the rectangle, we could push in and out. It's like the power of that end point there. That looks good. So curvature fans, check with, oh, look at that. It's twisted. But in this case, we use a different flattening tool. So inside blend curve, there is a planarize tool. Same thing as before, but it planarizes blend curves. If you use any other tool on a blend curve, it become a normal curve. So by using the blend tools, you keep it as a blend curve, with a little bit of smartness. No, a lot of smartness. Use layers I mean. So we put this into a layer, clean up a bit. So time to do a bi-rail. We turn off explicit and start easy. So actually we could reset everything. So we have more than 2 generation curves, 2+. And now we could pick these 3 here, accept, and then we go for the primary and the secondary, and nothing happens. But if you look at the prompt line, it says maybe we should try rebuild rails on, and that is because the mathematics is different on the opposite side. But with rebuild, we let Alias rebuild the curves into different mathematics to more match the opposite side, and try different combinations. It could be better or worse. Just try all different combinations until you have as few isoforms as possible. But if the deviation from the sides is not super important, you could also use explicit control. But then there might be some deviation. In this case, we went with the rebuild curve solution there inside bi-rail, and now we could just hide the upper piece. I keep the lower piece, and we're almost done. Turn on the zebra pattern and check, and here you can see the tessellation. You see this flat area, so we just go for the tolerance wherever it is, search a little bit. So there it is, and now we could make this smaller. See that? And you could even push in another 0. And now it's super nice to look at, and it's easy to evaluate. So especially look at the boundaries. Looks nice. We could also use the surface continuity tool, and it says, yeah, good. With a green C, we know we have curvature. With symmetry turned on, you could check there we have C, there we have C. So we have C as curvature. That is good. So I have a really good start now to continue on. But let's have a look at another tool that could also be very good. We have seen the zebra pattern, but here we have one where we could look at the flow on the surfaces in another way that doesn't change when you tumble in space. And it looks good. So let's save.